Welcome to Uncommon Courage, the podcast. My name's Andrea Edwards, and one of the things I try and do with this podcast is create the space for the big conversations we need to be having. There are no 20-second sound bites that are going to do this story justice. I focus on the polycrisis, so it's all aspects of the polycrisis and how it all comes together and interacts, and that's geopolitics, societal collapse, war, and of course all the way through to climate change. One of the communities, and it's a small community that I follow, are climate systems scientists. And the reason I follow them is because they get the whole story and they bring it all together. But specifically, what I wanted to do today is focus on impacts in the global south. So that's what we're going to do. And I am delighted to welcome Jan Umsonst, who's from Germany. He speaks really fast, so if you need to slow it down, do it. I love the fact that he speaks fast because, of course, I do too. But he positions himself as an Earth systems nerd on social media, which I like. Jan studies the changes in the Earth system, and he's all trying to about understanding what's coming next. He is also an Earth systems consultant, and he discusses the fact that we are now leaving the age of natural variability and entering the age of forced variability, where we're going to start experiencing the synchronization of feedbacks. And I think we're going to talk about that a lot today. So, well, welcome, Jan. I got through it. And I hope I said your family name right. So I first heard you speaking with Paul Beckwith on a podcast, and he's someone I've been following for a long time as well. So I just really, really enjoyed listening to you, and just thank you so much for saying yes to doing this with me. I appreciate it. I hope I do it justice. But do you want to just give people a little bit more background around about you?
I started to track Earth system changes from the year 2007 when I heard oceans are acidifying. I thought, wow, oceans are big. And if something that big is acidifying, maybe it's important. So I started to really read myself into it. And the more I read, the more I was fascinated by Earth, how it interacts, the biosphere with the physical processes, and what kind of system it is. It's really amazing system, actually, our planet. And with time, I did not knew that Earth is so complex. So with time, I discovered this topic and that mechanism and that system, and it got more and more and more. And so with time, I achieved like kind of overview on what is happening on the planet. And now we enter a phase, the non-linear phase of global change we enter now. Global change because it's not only global heating, we have to call it, but also biological changes in ecosystems, and changes in species in the oceans or the continents, forests. So it's much more than warming. It's also pollution of the biosphere is also coming now very important. But now all is interacting, like the polycrisis, how you name it, is now interacting, and it's more often than not interacting in a reinforcing way. And that's the problem. We shouldn't trigger every crisis at once, and that's insane.
Yeah. Yeah, and the flow on of those implications into society, and we're just seeing it, really happening around the world. It's funny. I when I first, like you, I've been doing it, but not just climate, also all of these other issues. And I'm like, wow, we're going to lose the global economy, and that's going to create this, and it's going to create that, and it's so. And then you've got plastics, and you've got the novel entities, and the nine planetary boundaries. It's big, and we also live in a world where no one's got any attention anymore. So it's like nobody wants to understand it. It's like, oh, come on. Yeah, it's interesting times for sure.
Yeah, I mean, we go against the static of our house we are living in. And if you go against the static, at one point, the roof will come down. And the same is with Earth. We go against the fundamental principles that keep our Earth system running to provide the living conditions we need to strive and prosper. And if we destroy these living conditions, you can't have a functional economy, for example. It doesn't work.
Yeah.
No
Yeah,
way.
exactly. Yeah, so I just want to give everyone some context, and then I'm going to hand it over to you. But what are the sort of the bigger issues? So I'm based in Asia. I'm in Singapore. You're in Germany. And it's very difficult to get the real perspective of what's going to happen in the global south. And there's there's loads of coverage in the global north. We're seeing Australia. We've got a pretty good grasp of that. English-speaking nations, right, predominantly. But like just in this last week, this catastrophic event is happening in Asia, and people say to me, "But nobody really cares what's happening in Asia." And I'm like, "Yeah, but you're going to care when your coffee prices increase again, and your tea prices increase, and rice, right? There's all of these floods across one of the biggest rice growing regions of the world is going to have an impact globally, and we've got amazing climate scientists right across this region. There's no question about it. But some of them can't speak because they live in a country where they can't speak freely. Some it's just cultural. People in this part of the world tend to be very, very humble. And the other thing is, of course, there's multiple languages spoken right across the global south. So, we've seen some really crazy stuff. So what I want to try to do today, and we might need to schedule another call, but let's see how far we can go. But how does this whole story come together specifically when it comes to the global south? And I thought, we're seeing things that have not happened before just in the last week in the weather systems, merging of things, a cyclone forming in a place that's never formed. But let's start with the big stuff, the tipping points. So, when I talk tipping points, it's obviously the Amazon dieback, the Antarctic ice sheets, monsoon disruption due to the AMOC and the SMOC, the coral collapse, which maybe we can talk about separately, wider glacial melt, like we've got the Himalayas, we've got in Latin America, we've got the glaciers there, Enso disruption, which is part of the story of happenings now. So what do you want to start with? Do you want to start with the Amazon or?
I mean, the point is first, like the general system nature we're living in. Earth is not a linear system. This means changes in the Earth system that don't happen linear, but most often abruptly and non-linear. So Earth is a non-linear system. It's very important to understand that. Actually, it can be a highly non-linear system. There the problem starts. The second problem is the nature of Earth. Earth is a water planet. Water planets are different than from rock planets. If you heat a rock planet, you cannot heat up the system too much. But if you have waste oceans, you have like a battery. The oceans, they store waste amounts of energy because of rising greenhouse gas levels. So the oceans, if you have an ocean, they accumulate waste amounts of energy. If oceans get warmer, they produce steam. And steam is like the currency that drives the economy of Earth running, that drives it. And if you get warmer oceans, you get more steam, and the atmosphere gets more energy. And if the atmosphere gets more energy, this means air movements start to speed up. In some areas, they speed up. In other areas, they slow down. So the variability starts to increase in the system. And if you warm a water planet fast, you can expect highly nonlinear reactions, especially if you go down in time and space. This means in a given region, in a given month, in a given week, you can see astonishing freak events wide off charts. So with the speed of warming, you get a higher number of these freak events that are far distance away from the historical means. So what we see now is that we get ever often extremes that are astonishing in time, in space, in intensity or scale, or in frequency. So what we see the last years is like just the beginning. And that's the problem we face. It's not anymore easy to predict how the system will behave, how extremes will increase in all their different aspects. Like you have droughts, you have heat waves, you have storms, floodings, you have large wildfires and stuff like this. So the question is now, how fast will global warming evolve? And what will be the effects in the subsystems of the Earth system? And as it seems, global warming will happen now faster And the effects on the circulation systems and weather systems and stuff like this are much more extreme than we thought they would be. So
Mm.
we enter now highly dangerous terrain.
Yeah. So, I mean, we still keep hearing it's going to happen by 2050, it's going to happen by 2100, but it's already happening
Yeah,
now,
it's happening
right?
now.
Yeah. And when you say the non-linear, because I think that's terminology that I understand and is used a lot, but I think for average people, they don't really get what that means. So do you mind just explaining that?
I mean, non-linear, you have like a clear line, goes steeply, goes slowly, it rises. If you have non-linear, you have bing, bing. Those so sudden, abrupt changes, they happen more frequently, they get more stronger. And these ping behavior, or sometimes ping, ping, whatever system you watch at, like sea surface temperatures, for example, global ocean surface temperatures that jumped by zero point 0.3 degrees the last 6 months in 2023. 0.3 degrees doesn't sound much, but the mean warming rates of the ocean surface had been about zero point 0.1 degree in 10 years. So you had suddenly a jump by zero point 0.3 degrees in 6 months in 23 that kept up in 24. So it was a massive jump in sea surface temperatures, and we did not
Mm.
saw it coming. Now it declined again, but these jumps they get likely bigger, and this is the main problem. That global warming accelerating means not the line gets more steeper. That's not the point actually, but the global warming does not happen linear or gradually. It happens as it seems like now to be the case via jumps. And we had a jump in 1998 to 1999. We had a strong El Nino in this time, a highly warm equatorial Pacific. And this warming jump went declined afterwards with a lot of La Niñas till 2012. So in the past, we had warming jumps, they declined again, and then it took a time till another jump came. And now we have the situation we had in 2014 to 2016 a massive temperature jump. But afterwards, the temperatures did not decline significantly afterwards. So we get now temperature jumps that come to stay. So we had 2014, 2016 one, also driven by El Nino. The next one came 2023, 2024, also driven by an El Nino. And this jump was even a little bit larger than 2014 to 16. And the astonishing thing is in 2023, 2024, we breached suddenly not only 1.5 degrees, but 2024 reached 1.62 degrees, like the mean of all these temperature data sets. So we jumped right from 1.2, 1.3, we jumped right to 1.6. Now we declined a little bit to 1.5 again. But now is the big question, when will the next temperature jump happen? And
Mm.
that's the nonlinearity we are most concerned with, because these temperature jumps, they produce a disproportional increase in extremes, likely. It's not sure because you don't have like 100 years of global warming data. It's
Mm.
just we learn while it is happening in a way.
Yeah.
So what we can expect is the temperature jump of 2023, 2024, that another one will happen. Likely it will become larger or as large as the last one. Why can we expect that? We understand now these temperature jumps in the system. They are driven by the oceans. This means living on a water planet means global heating leads to oceans accumulating energy. And from time to time, they start to give like a burp. They release
Mm.
energy to the atmosphere. And that are El Ninos. But now we have the case that the last El Nino also, it was a different El Nino, a different spiciness or different flavor it had. This means the convective areas during the last El Ninos were not located in the central to eastern Pacific, where most of the heat was pulled from the oceans into the atmosphere, but it was the Western Pacific and the Caribbean. These were the main connective areas. And so we had like a new kind of El Nino, which released also massive amounts of energy, but via other ocean areas, not the Central and Eastern Pacific, which also released energy, but mostly was these two centers. And that's the problem, that these jumps driven by heat released by the oceans into the atmosphere, they are likely to increase. So when comes the next jump? Maybe 2030, 2032, 2035, but maybe more earlier than the last one, like the frequency is shortening.
Mm.
And why
So,
is
so,
the... Hmm?
so I'm just going to ask that last jump. The scientists still don't fully understand why it happened, right? Or do you
The
think the
studies are
answers are
not...
coming in?
Yeah, they now came in actually. There
Yeah.
exists a statistical approach, statistical climate science and model scientists, but there exists also like the mechanistic approach, like what happened actually in the physical system that triggered these temperature jumps. And now the studies are mostly complete, or they draw a complete picture of what happened in 2023, 2024. And it all indicates that these warming jumps are also kind of feedback driven. And if we look at the reasons of what happened in 23, 24, before in 2020 to 2023, we had La Nina conditions and ocean heat uptake rates, they skyrocketed the last years. We have now a six-fold ocean heat uptake rates annually than in the 80s to the 50s, 1950 to 1980s, a six-fold increase now. And in the years 2019 to 2023, we had very high rates of ocean heat uptake. And then in 23, this heat was in part transferred to the upper ocean and released to the atmosphere, while at the same time we had a very large cloud feedback over warmer oceans, which means less clouds over warmer oceans. The oceans take up more heat, they warm faster. And this was
Right.
this temperature jump from the oceans. So you had heat accumulation, it was released to the atmosphere, and also less clouds increasing, feeding back on heat accumulation. And this is now the problem, that the ocean heat uptake rates, they are very, very high now. And at the
Mm.
same time, we had 2024 very high rates in CO2 levels increase, which were one third above old maximums. So this shows us that the next temperature jump comes likely more early than later. So 2014, 2016, you had 7 years to 2023 to 2024. And if you would apply another 7 years till the next one happens, would make 2031, 2 years
Okay.
on top. You have maybe 2033, or when the warming is realized. So we would approach 2 degree by that date,
Mm.
yeah? Or maybe preach it. So this is the craziness. All these discussions of 1.5 degree goals, or 2 points, or that we do not reach degrees, or if we will reach 2 degrees. No, we will reach 2 degrees of warming. That's set. We have
Yeah.
way too high rates of ocean accumulation, heat accumulation, greenhouse gases increases, that any reductions won't change it, that the next jump will come. And then we will see another rapid intensification of extremes. And that's
Yeah.
the big problem, because you told me about Southeast Asia and Asia, the extremes you had 2024, also
Yeah.
2025 now. Tell me, like, heat waves are very problematic now, huh?
Oh
Across the...
yeah. So I'll just put us both back on. So in 23 and 24, so we were still living in Thailand in Phuket, and it was we moved into deadly wet bulb temperatures, and we have no idea how many people have died across Asia and Africa and Latin America from these heat deaths. We just have none. And I was actually looking at some statistics, and I was calculating with AI because I'm not a maths person. And
Mhm.
in Africa, it could be 300 to 400,000 people dying a year. but they'll say it's between 1 and 200. This is the difference in extremes that we're talking about. But what scared me living in Thailand is the electricity is still up above the ground, right? And have you been to Asia?
I was sometimes. I was in
Yeah,
India, was in Thailand also.
yeah, right. So you've seen, the electrical cables. They're all these mesh of wires, right?
Mhm.
So it didn't get hot enough for the grid to collapse. I know in roads, there was a grid collapse when it hit about 48 degrees, and that
Mhm.
system is under the ground. Whereas in Asia, it's all above the ground. So I'm extremely concerned about the grid ability to hold its
Mhm.
structure during these heat extremes in India, Pakistan, Bangladesh. I mean, they're just getting absolutely decimated by the heat. So,
Mhm.
um, you
Crazy.
know, uh, yeah. So I'm very very worried about heat and where we're going, because a huge majority of people in this part of the world live with a piece of tin over their top.
Yeah,
They're not in a house, but even people in homes with air conditioning, if the grid goes down, you're not going to make it either, right?
that's the
So
problem.
I'm curious about that escalation, like where I know that there's already significant numbers of people dying, but like 2 degrees. I mean, we're on the way, and I just dark laugh when I hear that we've got to try and keep it under 1.5. It's like, yeah, right, okay,
Fully like.
but yeah, but like so when you're talking about this escalation, by the end of this decade hitting 2 degrees, which is game over for things like the coral reefs, even though they've already declared coral reefs have passed their tipping point, which I've thought for a long time. We've lost the reefs, we just don't know it yet.
Mhm.
Because they can't just keep coming back from these bleaching events, right? So yeah, so from that time frame, because this region is, I'm 70 kilometers north of the equator where I
Mhm.
am. It's actually cooler here.
Yeah,
The
yeah.
the
You
wet
can
bulb
see.
is, yeah,
Yeah.
but when you go north of the equator, or you go south of the equator, the temperatures are much higher.
But you have
So
humid heat waves, oh, that's the problem. The
oh yeah, it's
humidity of the heat waves, oh, that's
yeah,
very
yeah.
high sometimes.
Yeah, yeah. But Singapore's infrastructure is very much designed for heat. It was
Mhm.
built for that. That's how they got investment into the country. So they're very serious about protecting their citizens from heat. It's a government that's been taking climate change seriously for a very long
It's
time.
actually, it's technically Singapore is quite a functional government, or
Yeah,
would you
yeah,
say?
yeah, yeah, yeah.
Because
Oh
I
yeah,
have
it's
the feeling more and more governments become really dysfunctional in this world.
absolutely, yeah,
And Singapore is it's somehow an exception. Huh? They also
yeah,
give good money to the politicians.
yeah, yeah,
They
yeah,
don't
yeah.
have to
No,
be corrupt to come to the money.
exactly. No, I have deep respect for this country
Mhm.
and the way it's run.
That's what I see. Right
Yeah,
now.
Europeans and Americans wouldn't put up with it, but I think it works. It works culturally, and the government takes care of the people. The majority of the people in Singapore are taken care of, and you saw it during the pandemic. I was in Thailand where people were basically left by themselves. Here,
Mhm.
everyone was taken care of. They had incomes to stay at home. It was impressive watching
Mhm.
what was happening here,
Nice.
and people trust the government and they trust the scientists.
Mhm.
So it's pretty. It's a good model
Mhm. It's good
for the for
example.
the for the future that we've got coming. I think it's a good model.
I mean,
We,
what
we
we need and what's one of the central points, because we can cope with the extremes, but the money has to flow to the people or to projects that protect the people. Because in the end of the day, you always need the people. And so governments have really to take it serious to protect their societies from heat, flooding, and extremes. And most often than not, it's more of us evasion. We have to evade the heat coming at us. This means like
mm,
cooling centers, stuff like this, cooling centers in slums, for example, cooling centers in cities, shelter. You need to build shelters, cooling shelters in India. They need everywhere cooling shelters because in the mid time or midterm, heat extremes will intensify fast, and we are now already near the red or sometimes inside the red area already.
yeah,
And
yeah,
these massive heat waves Because what we observe is the most extremes, the most massive heat wave. That's the category that increases the fastest. So
Yeah.
that's the problem, that you get these massive heat wave peaks that start to persist for a longer time, bring the people over the edge with the heat they can cope with. A nighttime temperature that do not go down if you don't have air conditioning. You are trapped in a heat hell day and
Yeah.
night, and there's only so much we can cope with. And but we have, like I saw, one example. I mean, you have to help the people to cope with the heat. That's one of the main points. So countries have to start to redirect funds to save the populations, but I don't see that.
No.
um, that's really problematic because we can do something, yeah, but it will affect us in any way. Now, for example, a long heat wave for 1 month or 2 weeks or 1 month, people who have to seek shelter, often they are not able to work or to tend for their fields because it's too hot. So you have to support these people of the livelihoods, stuff like
Yeah.
that, income, stuff like this, and also education. You have to keep the education running. If children always have to stop with school because of heat, because of flooding, then you get populations which are not educated enough. So we need to protect the people. We need to protect education. So we stay in the game in a way, because if we want to mitigate global warming, that's what we will have to do. We will have to do not only reduce our emissions, but decrease the greenhouse gas levels in the atmosphere. If we want to do that, we will need all of us more best educated as much as we can do it, because we will have a lot of work to reverse the course Earth is heading to. So the first rule has to be in climate warming: protect the people.
Mm.
We need the people. We need their heads. We need their abilities. We need our abilities. So, but how is it in Singapore? You have the feeling lots of things are done
Oh
for
yeah,
time.
yeah. They're just, I mean, just covered walkways. I'll put us both up. So, covered walkways for people to get to public transport.
Mhm,
They're testing the white reflective paint on surfaces to
mhm,
reduce the urban heat
mhm,
island effect. But it's going to get
mhm,
uncomfortably hot. So it used to average 4 days a year of
mhm,
wet bulb temperatures. Now it's
mhm,
188 days a year. That was measured in 2024, and just this week the Asian risks report came out. So 90% of people living in across Asia will be exposed to extreme heat. Cambodia, Phnom Penh, it was like 100 and something, 150 something days above 35 degrees. And wet bulb temperatures have been downgraded to 31, but they're saying 35. And then there's like 50 something days above 41 degrees. So when you're
mhm.
in the tropics where it's really hot,
Humid, yeah.
and you've got the moisture in the air, and I look at the wet bulb temperature every day, and some days it'll be 41, 42 degrees, the real feel, even though the actual temperature might be 31, 32. And my son's
Mhm,
out playing rugby on a fake astroturf. And
mhm,
because the other thing that's happening, of course, is a lot of workers from Nepal, Bangladesh, Sri Lanka, Pakistan, they go to the Middle East to work. And within a couple of years, they're sent home because they've got kidney failure because
mhm.
they're out
Yeah.
in these extreme heat. So kidney dialysis units will be a massive need. You've got women working in the fields who are aborting their fetuses because
Mhm.
it's so hot, their bodies can't hold the babies anymore. So,
That's
um, but the other thing, of course, is with this extreme heat is it's destroying the crops. So if we save the people, there's going to be nothing left to eat. So in the Europe, you're seeing the rising authoritarianism, and people thinking these strong men are going to come and save everyone, which is the
no.
absolute exactly it's the absolute opposite of what we need, right?
Yeah.
We need strong leadership, but wisdom and empathy. But we also need
That's
politicians to really explain this is where we are, this is where we're going, and this is what we need to do to come together as a community to solve it, but also accept that there is going to be, people are going to die, these heat extremes. We're not going to be able to, the Thai Prime Minister at the moment is struggling to respond to the floods, and he's up for election next year because they sacked the last prime minister, right? Um, but no country in this region is ready for what's coming, what's happening. All of the responses are failed responses because they're just not ready for it.
I mean,
Indonesia's just lost 300 people to this cyclone.
this is,
You know,
no, the truth is the whole adaptation scheme, the whole discussion, the whole concept of adaptation is not gonna to work. We
yeah,
cannot adapt to a water planet that is fully escalating because we warmed it way too fast.
yeah,
And we do not even have the concrete to do it. The sand we need, because actually you speak about rebuilding most of the infrastructure structure
mm,
to be able to adapt to climate conditions, not in 230, 250, but 270, 280, to 100. So and we are now heading likely for runaway global warming if things go, if we are not lucky, let's say like this, if we are not lucky, we are heading for runaway global warming. If you look at the systems, you don't see it in the EPCC reports or single studies. It starts now emerge at signals in the system that we could have a trigger runaway global warming. So if we trigger something like that, while our ability as humanity diminishes to do anything about it because our economic system collapse and our societal systems, political systems, then we will be helpless in the face of an escalating, self-driven warming of Earth. And our civilization won't survive it. Our
mm,
economy, no chance, no way. Just take resources. The whole mining sector goes to open pit mines
yeah,
because you can dig deeper. It's cheaper to draw out minerals out of open pit mines. But with these massive rain events, these pit mines can really take out or can be taken out of business for weeks or months if a really
yeah,
strong event hits them. Because these terraces you have where all these they drive downward, you get mountain slides and stuff like this in these mines. And I don't
yeah,
know how long it takes to repair the streets inside these deep pit mines and bring out the water. So just from this point, the whole logistic, the resource sector, the electricity sector, the grid sector, for example, they all are not built to cope with the extremes we're triggering now. It's
yeah,
not the extremes we're triggering in 20, 30, 50 years, but what is happening since, let's say, 220, 219, 280, 18, it really started to accelerate. The last 2 years, we really have another intensification. So maybe just the next temperature jump, may it happen in 221, 231, 235, or maybe 240, but I don't think so. I think more early. But if this
yeah,
one happens afterwards, we are far in the red. Also in terms of non-bearable heat waves. And they're really problematic. I mean, you had in your post some numbers because it's really these massive heat waves, they will affect billions of people. And it's really the case what we can see now that large parts of the planet will become non-livable because of the heat wave. Just this point,
mm,
and it's just insane. But in the end of the game, global warming will lead to a state where there exists no regions on Earth where you have living conditions where you can thrive. It's really a global issue. We cannot escape from global warming or its effects. This means we have only one solution. We have a species, solve it. We really have to reverse the warming. Otherwise, we will break down.
yeah,
The physics of a water planet will win against us.
yeah,
No chance. And this is what you see now all across the tropics, for example, with this extreme flooding you have now.
yeah,
And uh, this intensification of extremes, it's a self-amplification process. So just if we just focus on extremes and the intensification of extremes the last years, it happened way faster and much more stronger than we predicted it. And the reason is that the system, like how weather systems function, how currents function, or how air movements function, or jet streams function, all these processes in the oceans or atmosphere, they are driven by small scale processes. And these processes we could not implement in the climate models or Earth system models because too much computational power. So they leave out all these small scale processes. But these are the processes via which the system change and amplify suddenly. And just to explain what I mean on a concrete example, what we observe now is that you get in one region a massive flooding event. If you have rain, you have water vapor that condensates to raindrops. This condensation processes releases the energy that was needed to evaporate the water back to the air when it condensates the water vapor. Although you get hot upper air streams that come down over a high pressure area where the air sinks again. And if this hot upper air sinks down, it compresses again and gets hotter than the moment it when it started to rise at most, although it starts to rise at warm, moist air and comes down in another place as very hot, dry air, intensifying a heat wave. So what we observe now that large areas of flooding are coupling stronger with neighboring areas of massive heat waves. So this is the steam machine aspect. So you get intensifying flooding events. This means you get intensifying heat events. And that's one of the problems we face. And both cells are like circulation cells. Away from the equator, they start to rotate. And a low pressure system rotating in one direction and a high pressure system rotating in another direction, they can couple stronger. This means while one provides hot upper air for the other one to warm really up, the other one provides the lower air that accumulates moisture to rise in the low pressure system again. So high and low pressure system in a warmer climate start to mutual amplify much stronger than it was the case in a cooler climate. So processes of amplification are speeding up, and this is then the moment where you can get these off-charts events suddenly. And what you observe now in Asia, these sudden jumps in hot days in a given region, these are these outcomes, this nonlinear behavior. This means further sudden intensifications, be it in intensity of heat waves, be it of scale of heat waves, or persistence of heat wave. You can expect that you get also in the future further jumps of intensifications. And if we expect that the system is intensifying in jump-wise character, and we are already near the red, this means we are very fast. We can find ourselves deep in the red in a given region, in a given season, in a given year. So you don't know when things go really off charts, when it will hit you. But the chances are rising with further warming massively. What you see now all across Asia with this flooding heat waves since several years, it really goes nuts. I
Yep.
observe a little bit India, I observe a little bit also China and stuff like this. Like the flooding in China is insane how much moisture the system pumps into China, for example, in a given
Yeah.
region season. And so we really have to take global warming seriously because all what we observe in your neighboring countries expected to become fast worse, and we have to be solidaric with each other. We have to take care of each other, or we have to strengthen our communities. And actually, we will need a different economic system. The
Yeah.
system will break down. That's
Yeah,
a
yeah,
given. It's now the current economic system is already a guna in a way.
yeah.
Just one example: there exists a faculty of actuaries in England. It's
Mm,
they analyze risks for the whole financial market, but the background risks, not specific risks of balances and stuff like this, or and the point is, they expect in a 3-degree warmer world by 250, 4 billion deaths or more than 4 billion deaths, economic decline by more than 50% GDP, and but these 3 degrees till 250, it's their worst case scenario. But
mm,
it looks like we are. It's even worse. It will be worse than a worst case scenario. So these numbers, 50% or more than 50% breakdown of GBT, domestic product, or that 4 billion people are dying, or more than 4 billion people. It's our decisions if this is happening. It's not
yeah,
a given that it will happen, because if we let it happen, if we do not react, it will happen. But if we react and really as a humanity and start to reduce not only greenhouse gas emissions, we have to reduce greenhouse gas levels, as it
yeah,
seems, because we have not too much, then we really have a chance. But if we think, oh, we can anyway do nothing, we have no chance to do anything, then expect that things get fast worse, and expect that it will happen in your life that the society around you breaks down. And it doesn't matter where on the planet you are, because we live in a globalized economy. All the economies are interdependent, and no economy can function on its own. So it will affect everybody. And also, this increase in extremes, it seems very extreme in the tropics now. But also, if you look in the subtropics or the further north, mid latitudes, you realize that the increase in extremes is also bringing countries also now on the brink, far away from the equator.
yeah,
Like, for example, Italy. They are in the middle of a fast warming Mediterranean Sea. And they have now flooding after supercell. Look at the American Midwest or central to eastern part of America. They have now throughout the summer, they have one flooding, 1,000 a year flooding event, flash flooding, tornadoes, heat waves. It's really crazy, the weather in North America, for example.
yeah,
So this weather craziness, it's really getting fast. It's really intensifying fast. So we have to accept that we won't win the fight against global warming. We won't be able to adapt, and we will have to react at one point. Currently, nothing happens. I mean,
mm, yeah,
COP30 was a big failure. Most countries still don't realize how urgent it is. But from an Earth system perspective, we would have to start now to bring down our greenhouse gas emissions as fast as we can do it. Because it's not clear if we get a cascading feedback reaction of Earth. The science is really fast mounting, and it really seems like the system can change fast in a cascading feedback reaction, and the stakes get ever higher. While on the other side, what we're doing is actually decreasing, and it's not functioning.
yeah,
So I really hope that more and more people will understand that the only way we come out of it is like as a community, if we work together as a species, because no country on its own will be able to solve it if we further escalate it.
yeah.
So I
Yeah,
really
so
hope.
I want to ask you about sulfates, because this is obviously a big discussion point in the scientific community, especially James Hansen and his team, right? So one of the reasons that I've seen that the Pacific Ocean warmed up so much is because China was reducing its pollution, which reduced the amount of sulfates in its environment, which had a heating impact on the Pacific Ocean. So one of my understandings is, so when you said we've got to reduce, not just reduce fossil fuel use, but we've got to reduce what's already up there, because every year that we release by comparison a tiny amount compared to what's already up in our environment, right? So, we've got all these people talking about DAC machines and all that sort of stuff, but it's the regeneration of our environment. Like 75% of arable land is used for farming. You know, these are industries that are publicly listed companies that are going to grow, and we've only got 25% more arable land, so we're just going to keep chopping down the forests. um, the mega fishing trawlers, we've got to get life back into the ocean in abundance. If we don't do, because that's another way to sequester carbon, right? So to me, it's like, if we're going to do it, we've got to really, really change our food system and so we can regenerate a lot of the farmland. We've got
We
to stop the mega industrial fishing trawling. We've got to do these really, really big things, and I just don't even hear those conversations happening.
no,
The
no, no,
scale.
no.
I always think there's a scale. We have a scale problem, and there are scale solutions, and it's not buying an EV. That's not the answer. And I mean, when you were talking about the mines earlier being flooded, I mean, the vast majority of mines are in really hot parts of the earth, so they could be out of action for months because it'll be too hot for the people to work in them. And even if they say, oh well, we can have robots, well, robots won't be able to work at certain temperatures either. So so that's not a
It's
solution.
that's not
But
working.
what that sulfate conversation, because my understanding is if we radically reduce our fossil fuel use without also radically reducing the amount of CO2 that's already in the atmosphere, then we're going to see a heat escalation. Do you have any thoughts on that?
Mm, the problem is we have warming in the pipeline. So we are now at 1.5 degrees physically, 1.6 degrees 24, 25 a little bit cooler than 24. So 1.5 we are now at, something like that. SOx, it's aerosols produced by burning of fossil fuels, for example, and they have a cloud seeding effect. So they brighten clouds, they increase their lifetime, they also increase cloud cover because clouds consist of aerosols out of which water condensates. So cloud seeds. And SOx emissions were seeding clouds in a way on a global level. We had about 120 million tons of SOx emissions in the 70s or something, where we peaked. Then we reduced SOx emissions till the mid 90s. Then SOx emissions started to increase again because of India and China. They increased their emissions massively. 2012, China, or 2010, 2012, China started to reduce its SOx emissions by, for example, China. India, they were still increasing. So these increases and decreases of global SOx emissions slowed down warming or accelerated warming.
Mm,
Depends on the phase you are in our development. As SOx emissions decrease, you speed up warming because you reduce cloud brightness, cloud cover, and more sunlight hits the surface. So clouds cool the oceans. SOx support cloud formation, so they help to cool the climate. And the thing is, our total cooling effect of SOx is highly discussed. What is the actually cooling effect? And it's EPC gives numbers around 0 degrees to 0.8 degrees. It's likely the higher end.
mm,
Um, so we have currently a cooling of about 0.6 degrees, 0.8, something like that in the pipeline because of SOx. Part of it had been realized by SOx emission reductions over the shipping lines in 2020.
yeah.
And but it had been only about 8 to 10 million tons of SOx. We are currently at about 60 million tons of SOx emissions after the EMO regulations. So the EMO regulations, International Maritime Organization, these reductions of shipping fuel sulfates, uh, they happened in 2020 and were about 10 million tons. So the discussion is now the acceleration of global warming the last years. How much of it was caused by SOx reduction over the shipping lines? And the problem is, if the warming we have now is feedback driven, then we are in much more worse territory than if the recent warming acceleration had been driven largely in part of SOx reductions. Because in one case, it's our doing. We
Yeah.
reduce SOx, warming accelerated. In the other case, oh, the system's internal feedbacks led to an acceleration of global warming, further amplified by SOx reductions. Well, that's a big question out there. And the problem is it's for the system. Although if you say it's SOx, you get from the system more gratitude because the system, the political preferences, they don't want to have people panicking over global warming. Though they prefer results, they're not alarmistic. But if it's not SOx or only in part, but mostly a feedback-driven acceleration, then we are in highly dangerous waters now. And it
Mm.
looks like that it's more a feedback-driven. In fact, also Hansen says in one post, it's two thirds is cloud feedbacks, one third is SOx because we have reduced cloud cover, reduced albedo of Earth, so the Earth takes more sunlight in than it reflects to space since several decades. And this darkening of Earth is in part caused by SOx reductions, but also by feedbacks that lead to a reduction in clouds. So we have now two things that works that reduce cloud cover and speed up surface warming like the Northern Pacific. That's reductions of SOx and feedbacks.
Yeah.
And likely it's more feedback driven. Yeah,
Okay.
why can we say the warming 2023, 24 is more feedback driven than SOx driven? The largest sudden termination effect we had 2020. And if you reduce SOx emissions, they are washed out of the atmosphere in the matter of a week or two. They don't stay long in the atmosphere. So SOx reduction, they produce a long-term warming effect because of a fewer cloud baseline. You have lesser clouds, lesser brightness. So this is then the warming over time you produce with SOx. But we had in 2023, 2022, we had the cloud feedback going maximum really high to October 2023. And though we had with ocean surface temperatures going sky high, we had the cloud feedback going sky high in 23. And likely it had been a warmer ocean surface reducing cloud cover. And that's one of the main problems we face with global warming. If ocean surface warming reduces cloud cover, which leads to a faster ocean surface warming, we could be in big trouble, depending
Mm.
on how strong this feedback is. And in regard to the North Pacific marine heat wave, which is very, very important for Southeast Asia and South Asia, the North Pacific marine heat wave, it started to intensify in the 2010s. And it became really extreme. In 2014 to 2016, we had the blob of the west coast of US, massive marine heat wave we had. Then you had 2018 to 19 other massive heat waves in the west and eastern part of the North Pacific. But then from 2020, 2021, 2022, 3, 4, you had a development of a summer marine heat wave that was on track to cover most of the North Pacific, of the extratropical North Pacific. It's a vast, huge area, this marine heat wave. In 2025, this marine heat wave covered nearly the entire North Pacific, the extratropical North Pacific. It was a massive, massive, massive monster marine heat wave. And this heat wave happens under high pressure. And high pressure, you have low cloud cover. So SOx is not too effective here because you need clouds or cloudy conditions that SOx can improve cloud conditions. But if you have high pressure, you don't have too much clouds anyway. And these high pressure driven marine heat wave, also by heat transport into the North Pacific and circulatory changes supporting high pressure over the North Pacific, it's likely self reinforcing what we observe there. And the North Pacific marine heat wave, it helps to stabilize the subtropical North Pacific high pressure system. And this high pressure system gets very large, moves more to the west to Japan, and it rotates clockwise. And this clockwise rotation brings the trade winds over the maritime continents, intensifies them. All the air coming over the Philippines, Indonesia, Malaysia, towards Vietnam, China, and all these countries, India, and stuff like that. So these winds, these trade winds over the Western Pacific are likely intensifying, and the surface temperature in the Western Pacific is also intensifying, also in the Indo-Pacific, and stronger winds over hotter surface oceans can produce much more moisture. And this is
Yeah.
what you observe then in the tropics, this massive rain events, because at one point the oceans in Southeast Asia and Asia that produce more moisture, although because of the tropical of the heat waves in the North Pacific and the high pressure system pumping more air towards Asia and warmer oceans. So you get more moisture on one hand, and the moisture transport into a given area where we have this massive flooding then. It also intensifies from time to time because you get, for example, stronger storms. A
Mm.
stronger storm has a large rotation, and it can really move large streams of air into a given region. So you get stronger surface winds over the Western Pacific. You get much higher in a seasonal character, higher sea surface temperatures, producing much more moisture. You get more storms, stronger low pressure system, which can move even more moist air into a given region. And then you get this massive sudden flooding events. So you can expect these things to intensify also nonlinear. And I see
Yeah.
all the time, I start at one point and then because
No,
it's
that's cool.
long
Yeah.
chains, because and in the end, but I just want to outline that what you expect observe in Southeast Asia and South Asia, all the flooding and heat waves, they are the result of global to regional amplification processes that lead to these sudden extreme events. And if you have a lot of factors, a lot of different factors that can contribute to an extreme event, which can all behave in a way non-linear, if they all align perfectly well to intensify a regional extreme event, it can become suddenly off charts, much more stronger than you had any extreme event in the past. For
Mm.
example, Vietnam. Vietnam had no rain events. 1.7 meter was one maximum at the local station. Another one was 1.5 meters some days later. The last record, highest record was 1.9 meters or something. So suddenly we
Mm.
get 1.7, and the other one was 1.5, but just regional extremes at one station. But around these stations, I
Yeah.
guess, not much less. So you suddenly get nearly double of what you ever experienced before.
Yeah.
And that's the problem. And that's just all these large scale circulation changes driven by surface oceans heating up and a stronger coupling with the atmosphere and interacting with regional conditions,
Yeah.
amplifying regional conditions. And these amplification chains, they get in a warmer climate larger, more systems can contribute to a regional extreme event. And the single components, they can peak stronger. So suddenly you get a massive marine heat wave in the North Pacific, even more extreme in 2027. You get a massive high pressure system over the North Pacific, rotating very strongly. You get strongly intensified trade winds over Indonesia and the maritime continent. You get at the same time much higher ocean surface temperatures around the Philippines, around Indonesia, stuff off the coast of Vietnam, intensifying the moisture production even more. And then you get a very perfect constellation of low pressure systems channeling, or storms in this case, channeling all this extreme moisture into one area. And
Yeah.
then it goes bam. And that's another thing what we learn. Um, Flash flooding is intensifying the fastest, well, the extreme cohort of rainfall. This is the intensifying the fastest, where you low levels, low levels of rain are decreasing, and all comes down at once. This is
Yeah.
like the general trend. But you have also another trend. So you get local flash flooding massively intensifying, but you also get large scale flooding events affecting multiple river basins. They are also increasing. So you get small scale events massively intensifying, like what the fuck happened? My village or my neighborhood is a river system. And you get large scale persistent flooding events that also are on the rise.
Yeah.
And you never know in which season you got hit by what.
That was going to be my question. So we are in the season of typhoons. We're coming to the
Mhm,
end. Philippines has had its 21st. That Vietnam flooding, the area was hit 3 times in 3 weeks. So it was
mhm,
probably even more than double. And then Typhoon Koto was coming through this week, and it turned at the last minute, but it then merged with this cyclone that formed in the Malacca Straits that came
mhm.
across. And then I haven't had a chance to look. It was supposed to dump on Thailand again, which of course has just gone through this 1 in 300 year flooding event, but I'm not sure which part of Thailand was going to be hit. But so there's seasonal times, so for the farmers, right? So I've got a friend in the Philippines up in the mountains who she's a
Mhm.
farmer, and I sent her a message, and the last time it was before the super typhoon, it was a typhoon before that. I said to her, if you've got anything that you can harvest, get it in now because a big storm's coming. And they got it in, and an hour later the rain stopped. And if they hadn't done it, they would have lost their crop, which is of course really important, right? So the reliability, I suppose, of time when things happen, that's also changing, right?
It's gone. I
Yeah,
mean, what you see, for example, remote is gone, but I mean, in the northern hemisphere, you still have colder temperatures in winter. Yeah, you have. Um,
yeah,
but the main point is that the seasonal character of our climate, regional climate, is changing and getting more erratic. For example, the Indian monsoon season is not anymore a monsoon season because it can happen anytime. That's
mm,
a little bit what is happening, for example, in India. Also, like the monsoon rain in China is changing. It can happen earlier, persist longer. Also, thing. And what you said about these typhoons merging, the point is, in the past, we thought that global warming is intensifying extremes. That was wrong. We were wrong. Global warming is intensifying extreme events, yes. But what we missed is that these extreme events, they trigger and reinforce other extreme events. And that's the
mm,
problem. So this means global warming intensifies extreme events, be it heat wave, flooding, storms, dry, moist conditions, whatever, pressure gradients. And these extreme events can then enable other events to become even more extreme. Because any extreme event in our atmosphere, ocean, is driven by circulation systems. This means an extreme event is triggered by circulation systems, but it triggers a reaction in the circulation systems. So the stronger the extremes get, the stronger their impact on neighboring circulation systems that affect distant circulation systems.
yeah,
And this is amplification chain is highly non-linear, especially if you look at the given region in a month or a week or a season, sub-seasonal scale, let's say. In some seasons, just things go. off charts. You think, what happened in this month or in this week or in this event? And so you don't know anymore how strong an event can get, because it's highly likely that one time in 1,000 year events after the warming jump 2003-24 we did not observe till now.
Mm.
And this means in our given climate state now, much more worse and intense extremes are possible than what we had the last 2 years. These highly
Wow.
exceptional class of events. So this is another problem.
Mm.
So in Asia, for example, with your typhoons, the problem is you have one typhoon that produces an atmospheric river or a region with high moisture in there. And if another typhoon comes and merges with this moisture, it's intensified. Or if what case you have now two typhoons merge into one off the coast of Vietnam, is it? Or?
It was, well, the Koto was on its way to Vietnam, to the
Mhm,
same sort of central part of Vietnam that had those three flooding
mhm,
events. And then it changed direction, and this cyclone that formed in the Straits of Malacca, and it's never been recorded in history for a cyclone to form there. It went across Malaysia and formed with Koto, and then it changed direction. So it was scheduled to hit Thailand with more
uh-huh,
flooding. So
mhm,
it's a tropic. It's been downgraded to a tropical storm. So it's not,
mhm.
but it's just a big wet event. Yeah,
So in a way, the whole ocean weather, ocean atmosphere system around Southeast Asia and Asia gets more active, as it
yeah,
seems. And if the
yeah.
whole coupled ocean atmosphere system gets more active, you get sometimes these freak events. And now a new study came actually out. It has just opened before the season, this our talk here. And the study found an oscillatory regime of the tropical circulation. And it's highly interesting. What happens is this oscillatory regime has a period of 30 to 60 days. It's periodically oscillating. And what happens is you get warmer sea surfaces in the Indo-Pacific warm pool. This means Indian Ocean, Western Pacific. You get higher sea surface temperatures. This then starts to a higher heat release to the atmosphere. The tropical atmosphere is warming in this time. This intensifies atmospheric circulations. Surface winds over the ocean strengthen. They cool down the ocean again via moisture production. And you get this higher active atmosphere with more moisture, more energy, warmer. Then you get all these flooding extremes, and then it calms down again.
Yeah.
So these oscillatory processes, they seem to intensify in a warmer climate. This means kinetic energy in the atmosphere, it has to build up in a region. It affects other regions, and then it dissipates again. Builds up, creates a lot of motions. Oceans get cooler again, get a lot of extreme events you get, and then it calms down again. And these build-up phases, that's the problem. That is oscillatory regimes between highly or much more warmer oceans and an intensifying atmospheric circulation. Uh, these produce the most massive events.
Mm.
And these oscillations, they will likely also intensify non-linear in a warmer climate. For example, you had now one extreme event was caused by the La Nina conditions and the negative Indian Ocean dipole.
Yeah.
This means you have a very strong sea surface gradients between the East and West Pacific, tropical Pacific, and you have very large ocean surface temperature gradients in the Indian Ocean. And both affect circulation cells, which can intensify and can produce massive extreme events in a given region because moisture is pumped into it in the form of a cyclone, for example. And this gradient intensification on these oscillatory regimes that can intensify for a time, produce massive extreme events. these will further escalate in a warmer climate. We get stronger gradients between regions in pressure, in temperature, in density, saltiness, whatever. Though gradients increase in a warmer climate, they produce movement of fluids, and movement of fluids in a water planet over warmer oceans produce massive evaporation events, which lead to massive flooding in one area and heat waves in other areas. Because
mm,
all the flooding of Asia, all this heat production for the upper oceans, upper atmosphere, produce the hot upper air that comes down in the extratropics and the subtropics, making all these heat waves. So it's all
mm.
connected.
Yeah,
Yeah.
yeah,
It's and sometimes you have in the tropics you have a flooding event fooling a neighboring heat event. Right? As you have, for example, northern India, you have western India, massive flooding, while east India, massive heat event, and both couple both
yeah.
systems. So
What about the Enzo, like the reliability of it? Because we're going into we're still in a La Nina, or it's back to a strong La Nina. So, um, this El Nino, La Nina, that is it just will keep going back and forth, but in it be extreme in both, or what's going to happen with that system?
that's the big question out there. Um, what we can expect, this is that El Niños and likely La Niñas will both get more extreme. Because that
Yeah,
is what we observe in all the systems. These oscillations become more extremes.
mm,
So likely also La Niñas will become more extreme. This means the temperature gradient shifts across the tropical Pacific will intensify. That's one thing. And this means if you get, for example, during La Ninas, the oceans accumulate more energy. And this is released to the atmosphere again via El Ninos. This means if you get more La Ninas, you get faster rates of ocean heat uptake, which are released in part to the atmosphere via intensifying El Ninos. Because
right.
if you get more La Ninas, you have to get more intense El Ninos. Because the system has to get rid of the energy. And this is what El Ninos do from a thermodynamic perspective. So
Yeah,
more La Ninas, not good, because they lead to more extreme El Ninos.
yeah,
Um, what we will likely get is more El Ninos, and sometimes we'll get super El Ninos, and sometimes we get very strong La Ninas. This is what we
yeah,
can expect. Uh, and most worrying is that the circulation cell over the tropical Pacific, you have a zonal cell over the equatorial region, but you have also meridional, north-south cell. Yeah? And these overturning cell in the tropical overturning cell to the north and to the south is regional intensifying. So zonal circulation, this Walker circulation, is also intensifying, especially on the event character. And these circulation cells, they couple stronger with neighboring cells. What you have a stronger coupling between El Niños and uh, positive dipole events in the Indian Ocean. This means you have a lesser temperature gradient actually in the tropical Pacific and a higher sea surface temperature gradient in the Indian Ocean, which couple stronger in the circulation cells. And this then produces extremes or intensifies extremes around the planet. Because if you have one circulation cell
mm,
intensifying, you have other ones as well.
yeah,
And this is what we can expect, that the different circulation systems in the different regions, they couple stronger with other circulation cells. And so you get likely stronger jumps, intensification in extreme events worldwide, driven by exceptional La Niñas or exceptional El Niños, coupling with other tropical, extratropical, or high latitude circulation cells. So likely, it seems like that the whole system is interconnected from poles to poles,
mm,
and that
Yeah.
sometimes you get strong El Ninos or strong La Ninas, and the circulation cells in other parts of the planet also go into hyperdrive, and you
Yeah.
get sudden intensifications of extreme events. And so we can expect that these shifts in extreme events or sudden intensifications of extreme events driven by El Ninos and La Ninas will intensify in a warmer climate. So
So
also another aspect that we can expect that these off charts event will happen more frequently and will become more off charts.
yeah.
And it's just it's a sad story actually because we are
Yeah.
already at the wall. But do
Yeah.
not expect in Southeast Asia or Asia that the extreme events will calm down again. They will
Yeah.
likely, and that's a big question, will they increase the next years without temperature jump? Or are or is the next temperature jump needed to intensify these extremes again? This is a big question. It's open.
Mm. Yeah. Yeah.
So
Right. So obviously spent a bit of time on Asia and Southeast Asia, but obviously in the global south we've got Latin America, Africa, uh, Australia, New Zealand, and the Pacific islands. So we've seen terrible, terrible droughts in parts of Africa in the last few years. Um, uh, Latin America, we've seen horrible heat extremes there as well. So when you look at those other parts of the global south, knowing that we're going into a strong La Nina, what are you expecting to see? What's going to be the crazy stuff that's going on there?
I mean, uh, I mean, one thing what we have to see is an intensifying tropical circulation affects mid-latitude circulation and affects the circulation in the pole region. If the circulation around the polar region get disturbed, it feeds back towards the tropics or even into the other hemisphere. This means that extremes on our planet, they are interconnected on a global level, and we can expect now that this intensification of extremes will happen in most places on Earth. There are nearly no exceptions. Germany actually is an exception in a way. Um, so if you take, for example, South America and the Amazon, for example, we had 2023, or we had 2005 massive drought in the Amazon. We had
Yeah,
2010 a massive drought in the Amazon. Was exceptional droughts. Then we had droughts in the 2010s, but not like 2010 and 2005. But then we had in 2023, 2024 the most exceptional drought over the Amazon basin, the rainforest there, and it was really off charts, much larger areas, much drier, much hotter than any time during past droughts. And so you get suddenly a massive intensification of droughts over a couple, most affecting most of the Amazon for nearly 2 years. And it was driven by ocean surface temperature pattern around South America. And the question is now, when will the Amazon, for example, collapse? It's between 1.5 and 2 degrees. It's now the estimates when when this Amazon basin will slowly collapse. But if we look at 2023 and 2024 in this drought, we can expect that these events will further intensify, and that, for example, the Amazon rainforest is now on the brink already now at 1.5 degree. So likely, for example, the Amazon will start to burn large scale, maybe on the road to 2 degrees, as it seems likely. We will mostly southern parts, but if the fires go up more north in the undisturbed Amazon rainforest. So, for example, the Amazon, if you get a burning Amazon, it's now a source. The whole Amazon is not anymore CO2 sink, but it's a source.
yeah,
So, if the Amazon collapses into a fire regime, it produces high levels of greenhouse gases. That's one point. So, it accelerates global warming. Then you get a drought state of the Amazon, for example, heats up the tropical sea surface temperatures in the Atlantic. So you get a chain reaction, you get warmer tropical sea surface temperatures, which then affects other areas. And you get, if the Amazon burns, for example, you get high loads of black carbon in the atmosphere
Yeah.
up to the stratosphere. We have now this new class of fires that produce so much black carbon, which they pump so high into the atmosphere that it goes deeply inside the stratosphere. This was not happening with all small fires. Though if the Amazon burns, you get high loads of black carbon in the stratosphere, which are distributed around the planet. And black carbon, for example, heats the areas in the atmosphere where it concentrates. So you get also in the atmosphere a fully new effect. And likely black carbon in the atmosphere, it can reduce cloud cover, for example.
Mm.
So just in the case of the Amazon and South America, you get crazy smoke levels for Brazil and neighboring countries. You get black carbon into the stratosphere. You get higher carbon levels or CO2 level in the atmosphere. You get massive phytoplankton blooms by the smoke deposition on the ocean surface. So just on the example of the Amazon, it shows that one of these important systems is that if it tips, it has a global chain reaction as a consequence. So this is what we can expect in South Asia, South America, that we will see a collapsing Amazon, more smoke accumulating across the tropics, and the smoke will also lead to higher rainfall levels, for example. More aerosols in the atmosphere and higher moisture level leads to the most extremes of rainfalls. But this you can expect. Indonesian rainfalls also had to blow the smoke plumes. So you can
Yeah.
expect the Indian rainfalls will also uh, burn at a much larger scale in the coming decade, which will lead also to more smoke in South Asia and Southeast Asia and also distant region, intensifying rain events. So, uh,
Basically, we're stuffed.
yeah,
Yeah.
it's not looking good actually.
No.
It's
No.
all interconnected, and also what you
Yeah.
can expect. The Arctic, the southern
Yeah.
polar zone, it's now heating fast because warm and moist air is now entering ever more often the Antarctic ice shields because the circulation around Antarctica gets increasingly disturbed. So you had more a zonal round flow. Suddenly the flow makes whoop, 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 makes a lot of curves, and it is disturbed in a zonal flow around Antarctica, and it wobbles more. And this is what we have now around Antarctica. The circulation cell around the Antarctica is more wobbling. It's not
Mm.
anymore so round, but it's more like and this creates circulation. This circulation affects then tropical circulations, which also feeds back on extreme events in Southeast Asia. So there's another problem. You get extreme convective areas in, let's say, in the Indian Ocean. They disturb the circulation around Antarctica, which then feeds back on the tropical circulation systems and causes abnormal circulation in the tropics. And so it feeds back on each other. And so the intensification actually it's affecting. I mean, it's South America, it's Australia, it's tropical Africa, South Africa, North Africa, it's Southeast Asia, it's South Asia, Southwest Asia, West Asia. So all these regions are now affected by the intensification of extreme, but it also goes up to England, goes North America. We see it now, Italy, or the whole Mediterranean neighboring countries are affected because the Mediterranean is heating up so fast. So actually, these intensifications you see now all around the planet, and they're all
Yeah.
interconnected. But the most highest levels of rainfall you have across the tropics because you have
Yeah.
all this moisture there. But also this moisture levels of the tropics, they're expanding also poleward. Also these
Yeah.
atmospheric rivers, when this tropical moisture moves far to the north. Also this is happening now more often. So there's
Yeah.
not a place not affected by global warming and extremes. You cannot escape. So
Yeah,
difficult
I
one.
mean, I was reading that the tropical system, as it now exists, is even going to be looking like moving down, so down, sort of more into Australia. I don't know if you've sort of come across that, but one of the things I wanted to talk to you about was the AMOC, because it's probably for some reason, it's one of the things that everyone's discussing, and for those who don't know, it's the Atlantic Meridional Occidental Current. I'll bring me up so I can give you a break. And Iceland, obviously, the government said it was a national, emergency that they focus on it. Um, so everyone in Europe knows about it. My understanding is that process will be quite slow as far as the deep freeze that will make Europe unlivable and North America unlivable. But this could be a stupid question, but I don't necessarily have people to ask these questions of, so I hope you don't mind a stupid question. So
I ask
when
them
that
all the
but when that current goes, and like I said, that's not a rapid thing. Well, it's not expected to be, but I don't know. You look at the pollution going straight up over the last sort of 100 years. I don't think we can rely on anything happening as it has happened in the past. Um, they talk about Europe going, or the North going into a deep freeze. Now, if the North goes into a deep freeze, are we going to then see there'll be enough? So the Earth energy imbalance will change because there'll be more white stuff to reflect the sunlight back. So would it cool the Earth down, or what? Because what I'm trying to work out is I've heard that it will just get really really hot in the south of the world, but no one's really answering that question. So if AMOC collapses, which will be a process, what does it mean in the north? What does it mean in the south?
I think it's all open. We don't know.
Mm,
I
right,
mean, one point is sure there exist studies that say sea ice will increase, the whole northern latitudes will cool down around Greenland. Um, Possible. But in the past, we had AMOC collapse, likely also when the Greenland ice shield was vanishing totally or most of it. So maybe it can happen that Greenland and sea ice recover and cool down a little bit. But this means you get higher gradients. While the tropical and subtropical region heat up, you get up there a very cold region or colder region. So you get a temperature gradients increase in this area. This means speeding up circulation.
right,
This is what it means. So if you get stronger gradients inside fluid, you speed up circulations. So you can bet you will get a speed up circulation and seasonal character and stuff like this. But what it means is if you have a very cold Arctic down to England, for example, and you have very hot tropics and subtropics, this interconnection zone where cold and dry air hits warm and moist area. And this
mm,
will massively intensify in such a case. So actually it
right,
means weather chaos, it means weather havoc, it means
right.
craziness, it means
Then
what
there's
is
nowhere to
happening.
go.
Yeah, yeah, it's there exists like some studies. For example, AMOC collapse is good for Northern Europe or North America or parts of North America because it counters global warming. And now
Yeah,
this
yeah,
is means maybe colder winters but hotter summers also
mm,
possible. Yeah,
yeah,
so you actually it's difficult to tell. But also this AMOC collapse, it's far from certain when it will happen. It's not even certain if it slowed down.
mm,
Measurements show did not slow down really, but some older ones do. No, newer ones they do not measure a slowdown. While model studies see a slowdown, but the AMOC collapse in the past, it means it can collapse in the future. That's for certain. It can happen maybe even fast. Normally, it should be more gradual, or if you have a high freshwater input in the North
mm,
Atlantic, can happen more faster. But it's for certain something that will take likely decades. Will not
mm,
happen next year, on 5 years, on 10 or 20 years. Will likely decline and suddenly maybe faster, but a process of decades, even not maybe even only next century. So the AMOC is of no concern. That's
Yeah.
my personal opinion. Because
Right.
our concern is the next 10 to 20 years. How bad will it get? And will we react as humanity? And for me, AMOC is a distraction
Yeah.
because it's nice to talk all day long about AMOC. Okay, there's facts, it can happen, blah, 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 blah. But
Yeah.
our problem right now is that the whole climate system is collapsing now. That's not
Yeah. Yeah.
happening in 10, 20 years. And that's our problem. And we do not know currently how fast warming can accelerate. Lots of feedbacks, they are not modeled by models because we have insufficient data or computational power, or we don't know the systems enough yet to be able to quantify the warming effect. Well, this means models are likely wrong in the prediction of the coming warming because they cannot simulate lots of feedbacks, which can have a very strong warming effect.
Mm.
So this is our main problem. Our main problem is global warming spiraling out of control.
Yeah.
And out of control means not out of our control, just out of control if we let it happen. But
Mm.
if humanity works together on a global level as one species, we can reverse this course. If we do not do it, I say every human being who is above around 60 and who will become 80 years old will be full into this shit.
Mm.
So the next 10 years, we will see a massive escalation driven by the next warming jump. And if the next warming jump happens, bringing us close to 2 degrees, things will go amok. The whole system will go amok. And that's the key.
Yeah. Right. Right.
Yeah,
No,
and
I like that. So it's funny. I expect to die of extreme heat. That's my expectation. My
yeah,
husband finds that a bit sort of hard to accept, but I'm like, I'm just looking at whether I'm in Asia or in Australia. That's kind of the path we're on, right? So I want to just go one more topic, and then I'll give you. I'll let you go because I know that this gets exhausting when you talk a lot, right? But the coral reef. So I come from Australia. The Great Barrier Reef is one of the most magnificent things I've ever seen in my life, right? And so it was recently announced that that tipping point has passed. I've been saying for years we've already lost the reefs. We just don't know it yet. Um, the fact that it was officially announced as it's gone, um, it's like the media coverage on that is just nowhere. And I'm like, this is probably the biggest story in the world right now that no one's talking about. So, I was sort of sitting there, and I was thinking about it, and I've sent you my sort of analysis of what I think is going to happen, right? So 25% of life on the reef will go with the collapse of the corals, right? So that's the creatures that live in the reef, rely on the reef, the actual corals themselves, and everything else that goes with it, as well as the species that come in and have their babies in the reef, right? So that's stage one. That's 25% of life in the ocean, and within 1 to 5 years is my estimate that we'll start to see that really happen. But then there's stage two, and that's like I've said, 30 to 40% loss of the rest of the species in the ocean because they rely on life in the reef, and on it goes to stage five, and basically we've lost 95% of life in the ocean, which is a dead ocean, which, as you were saying, it's a water planet. So that's 20, 30, 40, 50 years away. But the loss of the coral reefs to me is like that's an end game. Am I wrong?
it's um, we live on a water planet. The oceans control the living conditions on Earth, that's for sure. And it's the living systems inside the oceans which run to a major share the geochemical cycles of the planet. This means movement of carbon, movement of nutrients, movement of like aerosols for the atmosphere, for rain, stuff like that. So actually, the oceans, they control the conditions in the atmosphere and the land masses. That's what they do. So if you destroy all the complex systems in the oceans, coral reefs, kelp forests, seagrass meadows, and all this important, or mangrove forests, all this important system, if you destroy all these complex ecosystems, opportunistic microbes take over.
mm,
And what you see, for example, in collapsed reef systems, mats of cyanobacteria are growing on the on the seafloor. So what you have, for example, if you stay with coral reefs create a low nutrient environment, oligotrophic, though you have few nutrients in the water. That's what coral reefs do because they don't like nutrients, they don't like eutrophication. If you have a collapsing reef system, coral reef system, it's overgrown by macroalgae. Then the next step, you have a lot of new microbes, single cell organisms taking over the system. You have a high biomass alga blooms and macro alga growing on the seafloor, also producing lots of biomass. This means to fall oxygen levels. You get dead zones, which lead to more nutrients being washed out of the seafloor. So this means where once a nice, colorful coral reef system has been, slime, toxic slime takes over. That's, you
mm,
can bring it down to that because many of the microbes that are now spreading throughout the oceans and along the coastlines, they produce toxins and they produce high alga mass blooms because the food webs in the oceans get increasingly disturbed. In the past, for example, a reef system, you had these coral reefs in symbiosis with alga. They gave a lot of habitat for fish. They control each other, though they could have all prosper in coexistence. If these systems break down, you get systems dominated by microorganisms. And microorganisms, they don't like it clear and nice and
mm,
shiny. You can see white and far in the water. They like it slimy, murky, stinky. That's what microorganisms love. This is what we
mm,
observe everywhere. So if you collapse the complex systems in the oceans, you get systems controlled by microorganisms. They fool the microbial loop. This means microbes produce biomass, which is used by other microbes to feed on this biomass. In the past, you had a small copepods, zooplankton, that were feeding on the alga blooms. Fish were eating zooplankton, and other predators were eating the other planktivorous fish. So these chains, they brought nutrients to higher levels of the trophic levels. But now we get the microbial loop strengthening. This means alga blooms feeding algal blooms,
mm.
which become now in many cases toxic, neurotoxic. So we have now along all coasts of the planet the spread of toxic or neurotoxic, highly toxic species. Um, be it on the seafloor, be it in the water column, in the shelf seas for mainly, where we eutrophiate the coastal systems. So we get now since 70, 80s, we get now toxic species and the blooms spreading along all continental coasts of the oceans. And now a new study came out that a neurotoxic diatom species, Pseudonychia, which is spreading also along all the coast from pole to pole, is also spreading throughout the oceans.
Mm,
So the main problem is not actually a collapse of reef systems, but the main problem is we speak now about collapse of our oceans. And
yeah,
if the food webs of the oceans collapse into systems dominated by microorganisms feeding other microorganisms, not only more fish and zooplanktons, things can fast spiral out of control. There
yeah,
exists, for example, a scientific discussion during past mass extinctions. One of the questions is, alga blooms near the coast, they increase massively. This we know. That's
Yeah.
given. Yeah. But we do not know if they did increase massively in the open oceans. There exist discussions that say yes, others say no. And that's the big problem. Can the whole ocean collapse into a a system governed by harmful alga blooms also across the upper oceans? And I would say yes,
Yeah.
because they have all the functions to do it. But we play a highly dangerous game here.
Yeah.
Because if you live on a water planet, first rule, the oceans are sacred.
Yeah.
If you destroy the oceans, you're a gooner.
Yeah.
That's like this is just I mean just common
I
sense.
know. I
Tells us
know.
you cannot destroy the ocean on a water
I
planet
know.
because you don't
It's
know
crazy.
what happened. You don't know what
Yeah.
happened.
Yeah. And we're seeing that algal bloom impact off the coast of South Australia. Just for the last sort of 6 months, it's just devastating what's happening.
Yeah,
So
yeah,
yeah,
yeah.
you know,
The largest one was off the west coast of USA. 3,000 kilometers of neurotoxic alga bloom for a month. Was
yeah,
2016 and was repeated now again. Last year was it? So if you get toxic alga blooms covering 3,000 kilometers of coastline for a month,
yeah,
what kind of warming you need actually? But it's all disregarded because if we want to solve just the alga bloom problem, we would have to solve global warming,
yeah,
how we use nutrition on the agriculture sector. We have to
yeah.
protect coastal systems. You have to stop pollution coastal systems. We have to
Hmm.
stop fishing and all this bottom trawling fishing
Yeah.
nets. You have to stop that. So you have though
And
actually
deep sea mining.
yeah. What do you want to top deep
Yeah,
sea mining? I
yeah, I
mean,
know.
this is not stupid. This is far into the insanity area.
Yeah,
We are
yeah,
not anymore stupid. We are just insane.
yeah,
We are an insane species. It's just madness. And the problem is all the whole world, the whole economic system is based on all these processes. And
yeah,
if you want to change our behavior, the whole economic system would have to collapse
yeah.
because just we have now what about $250 trillion of debt, or is it already $300 trillion of debt
Hmm.
to pay this all these interest rates? You need to destroy. You need to keep up all these markets running. You
Yeah.
cannot just change our behavior without destroying the whole capitalistic economy. This
But
debt,
we're gonna destroy it anyway. One way
that's
or another, it gets destroyed,
no
right?
chance, no chance that, yeah, it will anyway collapse. All this
Yeah,
debt is unsustainable. And also, if you want to adapt, if you want to mitigate global warming, we cannot do it in depth like that.
yeah,
So actually, we need a fundamental reorganization of humanity to solve the existential crisis we are now triggering. That's not a wish concert. This means we don't do it. That's it for our civilization.
yeah.
Maybe 10.
I yeah. I've got. We decide. Nature decides. That's
That's
kind
like
of
this. Nature
you
will
know.
decide
And
for us. Maybe
exactly.
it's maybe in 10 years we are already fully in the red. Maybe in 20 years. But don't expect it to that it takes much longer.
Yeah.
20
And the
years,
word.
I said 10 years max, because
Yeah.
we need just the next temperature jump. But sure, it's not about right or wrong. It's just that it will happen. That's not sure. The only question is how fast will it happen?
And those
And
bunkers aren't going to be much use either, right? The billionaire bunkers aren't going to be much use in that future. It's
no,
yeah. I
I
mean,
mean,
yep. It's just it really is. And I suppose one of the reasons I wanted to get you to talk is people don't want to hear me talk about this stuff. They really don't. They really push back on it in social sort of conversations with people who don't think about this stuff. They really try and censor it. Oh, we're not talking about serious stuff. We're not. And I'm kind of sitting there and I'm like, guys, if we don't do what we need to do, we're really going to be in a lot of trouble, and we're already in a lot of trouble, right?
Yeah, it's
Um,
just
and it's a very difficult thing to sort of, because I'm part of communities that think about this stuff, talk about this stuff, try and educate the world about this stuff, but they've the majority of people, they just don't want to know, and I'm like, you're going to know one way or another. You're going to know, so it's better
no
to know
chance.
now when we've still got maybe a chance. We've got to try. We might not succeed, but I'd like to try. I've got a couple of kids. I'd like them to be able to go out and be heavy metal rock stars and pursue their dreams if that's what they want, right? But we're not even trying.
No,
we're,
it's
we're just not.
no,
You
it's
know.
just. I mean, the problem is the elites. They do not realize it because you really have to occupy yourself with it. And one thing what the system tries to do is like they try to keep these politicians in a bubble.
Yeah,
Everybody has his own bubble. For every social layer, you have bubbles actually,
absolutely.
and
And
every group,
billionaires too.
all in their bubbles.
Hmm.
So politicians they do not realize what is happening in the field.
Yeah.
Uh, some maybe also the billionaires. I don't think they realize what is happening. Otherwise, the
No.
Trump regime would not give a fuck on emissions because
Yeah.
they see it in the moment or parts of it as a geopolitical instrument. I don't know why the U.S. government wants now with all its might to increase its emissions. Actually, it's an attack on humanity what the U.S.
Mm.
government is doing just now. I don't know, but it tells me that they do not understand what they trigger here. Also, these billionaires like Thiel and stuff, they have
Yeah, I
their
know.
mansions in New Zealand. They think they go with all collapses, they go to these mansions. And then when all is collapsed, they come out again and take over the markets, produce food with bacteria tanks and stuff like that. Some fantasies like this they have. They really think they produce a collapse, then they wait till the collapse is over and then they can rebuild. It's no.
I know.
After collapse, nothing. So actually, the collapse of humanity has to be prevented because if we collapse, we cannot do anything against it. So
Yeah.
that's the main thing. If the current system keeps on doing what it does, it will collapse. No, no chance. This
Yeah.
means all these trillions, all this will be gone. They will
Yeah.
be gone. So best to transfer it over into a new system that can survive. This means we have to get rid of all the debt to create room, maybe inside the same system. I don't give actually, but we need a lot of money, a lot of work power actually to reverse what we did.
Yeah.
And there won't be any chance for this world we have now to survive. You just need to, just with the grids in Southeast Asia, you need to rebuild all the grids.
Yeah.
Also in the industrial countries, they are all not built for what is coming. So just
No.
that,
Yeah.
rebuild all the electric grids of the planet. We don't have the copper, for example, difficult. So we really have to be inventive. We have to be smart. We have to be efficient. But this
Yeah.
system prevents us to do anything because you don't want to have good grids. You want to have make money with grids. But if you
Yeah.
have to invest money in grids, you don't make money out of grids. So this whole system is not made for what they trigger. And this, I guess, will be realized by ever more people. It's like Trump is the best example. All the Republicans, they were sticking with Trump because they realized only if we stick with Trump, we have a future. Now that Trump is collapsing in his regime, now ever more Republicans are jumping off the ship because they realize if they stay with Trump, they go down. They have to leave the ship to stay on top. And this
Yeah.
means in terms of climate warming, more and more people will realize the next 10 years that with this ship, they have no future at all. They need a new ship. So it will create a massive movement on all society levels because all realize they have no future. No? Because also billionaires and rich people, they all have kids.
Yeah.
They ask them also, that personal level it also has for them. So I think we will get a big movement, global movement, the next 10 years of humanity realizing if we go on, nobody wins.
Yeah.
Just nobody. No winners. Only
Yeah.
losers. So hopefully our species will work together and will find
Hopefully.
together. And I think
Until
we
I
must
until I
do.
see yeah, until I see that level of, protest on the street, you see climate protests and it's thousands of people, and then you're like, I'm like, until everyone is on the street, people are not appreciating the situation that we're in. I mean, this is a time for a complete revolution and
Yeah,
how we
yeah.
run our societies. And every
That's
country is going to deal with it differently, right? But war is not the answer because that's just going to exacerbate the situation, right? With all the emissions that come from war and all the pollution. Ukraine is devastated. Gaza is devastated from an environmental
so
perspective.
sad.
We can't. That's not the path, and that's where the leaders are taking us, Peter Thiel and all those sort of people that you were
Yeah.
mentioning, right? It's just we do not have the right people in power in Western nations. I do think that in some areas of the world, like I in Singapore, I think the leaders are very much operating in the interests of their community, but no country can start this by themselves, right? And it's that collaboration that's necessary, and we didn't. Maybe that's one of the outcomes from COP30 this year: countries coming together, working together, a smaller group. I don't know. We wait and see, but it's time. But yeah. So, and then the other thing, of course, is there's still a lot of information we don't even know, from a climate perspective. There's parts of Antarctica that scientists have never been able to reach, so there's, you were talking about the small things and the big things, there's so much we don't know. There's so much we don't know the temperatures that are happening. We don't know how many people are dying from extreme heat events. But there's so much data that we don't actually have. So we actually don't even really understand how big the problem is either. So, I think that's where there isn't information is also information, right? You must, as you've been digging into the climate system, you
Mhm.
know where the information isn't as well as where the information is, and
Mhm.
I think that's a really important part of the conversation too. There's a lot we don't know.
And currently, it's a lot we really do not know how it will accelerate, how it will intensify. It's now open.
Yeah,
But it looks like that we really underestimated to warm our water planet. What will be the effects? It's
yeah,
likely much more worse than we thought. But I really hope that our species will come together because of that.
yeah,
Otherwise, I don't see really hope for our species because we don't change our course in any area. It's all over the red lines:
yeah, yeah,
pollution, destruction of ecosystems, biodiversity loss, introduction of novel species inside,
yeah,
stuff like that. You have global warming, you have acidification, you have harvesting of the oceans. I mean, everything, just the pollution. We toxify our whole planet now.
yeah,
Even then, the effects of microplastic
yeah.
are
I know.
now a planetary emergency already
Mm-hmm,
now, because we
mm-hmm.
just realized what microplastic does with us. It's just unbelievable what we do.
Yeah, and we
And
got and we got nuclear waste melting, ready to melt out of the Arctic after it was dumped. Yeah, it's just like anyway, Jan. I want to say thank you so much for joining me and for just being so honest. Maybe every 6 months we can catch up and you can tell me where we are and help
I
let
too,
everybody
yeah.
let everybody else know. But I just really appreciate it, and you communicate in a fantastic way that I think most people can understand because I think climate scientists. It's just so hard. It's so big. It's so complicated, and it takes a lot of time, right, to
Yeah,
pull the
yeah,
pieces
absolutely,
together, right?
absolutely,
But
absolutely.
yeah, you do it well, and I like that starting point of the water planet and just sort of emphasize, yeah, because
I
that's
mean, I just needed 18 years to understand that.
yeah, 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 yeah,
I
yeah,
mean,
I, yeah,
it's
yeah, I
just
know.
it's really take time sometimes.
Yeah,
Often it takes time for us to realize things or the true scope of things.
yeah,
Okay, so I
yeah.
also really appreciate to talk with you, Andrea. Also nice that you took your time, and I think it's very important that the information comes out there.
Yeah.
that we are
Because
on
yeah,
course to disaster. That's
yeah.
period. Only
So
question is one building at home.
every single one of us got to do everything we can. That's it.
Exactly.
But and I always say start with reducing your energy and material consumption by at least 70%. If you can do that, that means we stop flying, we stop holidaying abroad, we minimize our clothing purchases, we reduce our meat or don't eat meat at all, we get rid of our car and we use our legs or get on a bike or whatever it is, but just massively reduce. You can't do it overnight. It takes time. But once you start, it's amazing. Once you start and say, well, I'm not going to do that anymore, then you'll see the next thing and the next thing and quickly. And it's really liberating. It is because
Exactly.
it frees you up. You stop being caught up in the consumption society where having stuff gives you status, because it doesn't, and it's destroying the
Consumption does
foundation
not
of
make you
life.
happy.
No, and it doesn't, right? So
Yeah.
holiday local to home, and get out there and regenerate your little part of the world. Do whatever you can. Yeah.
Speak
So
with your friends, speak with people
yeah,
you meet. Also very important. Yeah. And spread the message like what you do with your podcast. So important.
yeah,
So hopefully we reach a critical mass of people, of
yeah.
humanity, understanding what is at stake.
I'm
In a
going for 1
sense,
billion people.
yep.
That's my
Good
goal.
plan. I love it.
Oh,
I mean, actually, you have to
it's
think big. That's the
yeah.
point.
Oh, it's the
Good
only
point.
way.
Yep.
All right. Thanks,
See
Jan.
you.
Appreciate it.
I have
All
to
right.
thank you. Yeah. Bye bye.
Yeah.
Uncommon courage.